There comes the cat. Hello, everybody. Good morning and welcome to OpenCV Weekly. I'm Dr. Sacha Malik, CEO of OpenCV. And our guest today is a success story from OpenCV AI Competition. His name is Bart Trzynadlowski, whose VR laser tag project took first place in the North American segment of OpenCV AI Competition in 2021. And I'm so excited to announce that his new company is building out this exciting project that started with the competition. And they are just driving the technology further and further. So that's very exciting. But first with me is Phil Nelson, who is the Director of Content and Creative at OpenCV.org. And if anything goes wrong with this webinar, he's the producer. It's his fault.
That's absolutely accurate, and so many things have already gone wrong today, folks. But it's me, the co-host with the co-most, the second banana, who is second to none, your plus one and only, and the show must go on. I'm Phil Nelson, here to remind you of a couple of things we do every single week here on OpenCV Weekly. But first, a quick note about the OpenCV AI Competition 2022. For the spatial AI track of that competition, a few of you have said you needed more time to send in your proposals, and so we're giving you a couple extra days. The deadline is now September 19th. So please, get those. If you've already submitted as well, you have time to polish up and resubmit if you would like. So the deadline for the spatial AI track of OpenCV AI Competition 2022 is now September 19. It was going to be today. We're giving you a little extra time because we love you. Here on the show, we do a couple of things every week, one of which is a giveaway to you in the audience. So stick around for that later in the episode. I will ask a trivia question based on the slides from our guest, Bart, and the person to answer that correctly here in the Zoom chat will win the OpenCV course of their choosing. Also, we're taking Q&A from you in the audience wherever you're watching, be it Zoom, Twitch, Twitter, Facebook, YouTube. Ask your question in the chat, and we'll do our best to get to the most interesting ones during the episode. Back to you, Satya.
Welcome, Bart. We are so glad to have you here. So the show is all yours. You can start by first actually pronouncing your last name properly, which I butchered, I know. So welcome.
Thank you. Thanks for having me. But yeah, my name is Bart Trzynadlowski, and I'm here to talk about basically, kind of how I went from the OpenCV AI competition last year to doing a startup, and specifically kind of what that startup is, and also how it ties into computer vision. And we'll get into some fun stuff. And I also look forward to questions and discussion later. So I titled this, from computer vision to sports 2.0. And again, I'm Bart Trzynadlowski. You can follow me on Twitter. To kind of, I generally try to post. I try to keep it mostly on topic and post, projects that I'm working on. So my interests are AR, computer vision, also, emulation and some other things. Basically, just kind of nerding out there on Twitter. A little bit about me professionally. I've actually done a lot of things, but I've been in the augmented reality space since about 2016 when I got a Microsoft HoloLens. That really opened my eyes, literally and figuratively, to kind of the magic of like XR in general. And from 2018 to 2021, I was at Apple working on AR. And it's interesting what happens at Apple when you leave is that they actually, people don't actually know this, but once the company's very secretive, and once you leave, they actually take you to a room in the basement of Apple Park and they erase your memory. So unfortunately, I don't remember. I can't say anything about what happened there.
It makes a lot of sense, and there's also a long recovery period. I hear you got to relearn how to walk, all that stuff.
Yeah, it was brutal. It was brutal, but here I am, back at it, and I'm trying to make up for that lost that 3-year black hole.
Hey, we've all been there.
So so I left Apple in it was September 2021. And so at the very end of that, after that, I came across the OpenCV AI competition, which actually kicked off like earlier in the year, and I thought it was pretty interesting. It was really like up my alley, and I brainstormed some ideas, and what I decided on was to think about how to replicate something called the void. Now, a lot of you might not have seen this experience, but basically the void was, and I think they're coming back, a pretty pioneering. I guess you could call it like it's a virtual reality experience. If you want to get really technical, maybe augmented virtuality or something like that. But basically, the way the Void worked is you would go to like locations. They had a few of these around the U.S., like literally just a few. I first saw it in New York. Their headquarters was in Utah. They have it in California. They'd have like a purpose-built room. So it's basically just like a bunch of like featureless partitions and so forth. But the things that you'd put on a headset and a backpack, and it was free roaming, tracked with motion tracking cameras, so it was all very accurate. And basically, like every surface that you'd see in the void, you could touch, and it would actually be a physical surface because they have some sort of like a physical prop there. So, like if you saw a couch, you could actually sit on the virtual couch, but it would also be a real couch. So the experience that I first tried was the Ghostbusters. Then they had like a Star Wars experience. And like this scene here was actually, this is concept art, but there was a scene like this where you go with like your friends and you'd have a shootout with these stormtroopers over like this lava field, and you could actually feel the heat from the lava because they had heat lamps like staged around. So it was this really really trippy experience that relied on super high fidelity precision tracking. And this was done years ago. I think the Void probably dates back to like I want to say 2015 or so, or maybe even a little bit earlier.
This would have been like right around the time that the Rift shipped, and I think the first Vive was out around then. Is that
Yeah,
good
I think
memory
so.
as well?
Yeah, they were using Oculus Rifts as their headset.
Yeah.
Yeah, exactly. So probably earlier than 2015 actually. Definitely a really pioneering experience, but it was extremely expensive. I think like void locations, you're talking on the order of like certainly over $1 million, probably maybe
Oh
even
yeah.
like a couple $1 million per location or more, primarily due to the cost of the tracking cameras that they used. So the question, so like on the left here, is an OptiTrack camera. That particular model of camera retails for about $5,000. They have cheaper ones, but they're still in the thousands of dollars. And more expensive ones. There's also other companies like Vicon and so forth. They're basically just
Yeah.
infrared tracking cameras, and what they look for, you can see that big ring of LEDs around it. They flood the space with infrared light, and the headset and the various props and stuff all have these like little retro reflective balls, basically like these little constellations of balls that you put on. If you ever see like when people do motion tracking, motion capture for like Hollywood, they'll be wearing these suits and they have these little balls on them, and that's what that's looking for. So it only sees the reflection from those balls, and it's very very low latency, and so forth. Super expensive, and you need a ton of them because their field of view is fairly limited. And to get good coverage, they end up like basically installing a huge like array of these on the ceiling. So that's where like the 7-figure price tag comes from. Not
Yeah.
very scalable, obviously. And as we know, in the last decade, computer vision has been getting pretty phenomenal. Amazing things are happening, and so it's one of those stories where the bottom end eats the top from the bottom. And I wanted to see, when I
Yeah.
heard about this OD camera, it was pretty exciting, and I wanted to see like, hey, I think we're almost at a point where we can do void-like experiences, using cameras that are just a few $100, and if you just put a little bit of like elbow grease into it and are a little bit clever, I feel like I felt that you could probably pull something off that was pretty similar. So yeah, so what I did is I decided to, this is a rendering, but this is kind of the concept for mixed reality laser tag, as it became called. The idea is that you're in your room with a headset. If we had a couple of depth cameras, could we basically understand the room and then reskin it to create like a new environment where all the walls and stuff still correspond to like physical walls, but it's like it looks completely different. So you see here, like I've replaced the walls with like kind of shorter walls with a city behind them, and all the furniture has some like obstacle around it, some orange box basically. Um, I'm not really an artist, so this was all done from the assets score. But that was like the objective. It's like, could I turn a domestic, room in a house into something like this using purely computer vision? For with a few $100 of equipment plus a PC and a standalone VR headset, which at this point are very cheap. Like the Oculus Quest, $300. Amazing progress since whenever the Void came out, circa 2013 or 14. And here's kind of like a split shot of from the video. There is a video on my YouTube account, or if you go to my Twitter, you should probably be able to find it pretty easily. And this is kind of showing us a swipe on the right side. There's like the real room, and it's like me and my mom actually playing a game of laser tag in the physical room. So here you go. Here's like the full scene. Hopefully you guys can see. On the right, there's the two of us rendered as avatars, and the walls correspond exactly to the walls in that room. The orange boxes are a couch and a suitcase. The reason is this was a prototype. I had a model that detected like a specific set of stuff. It didn't detect bookshelves, but it did detect couches and suitcases. So I dragged the suitcase in the middle of the room to see if it would pick it up, and it did. So this is how it kind of worked. This is another room. Basically, I was using mask RCNN for those that are curious to segment out and detect instances of various objects. So like couch, potted plant. It has all these the default model has I think 20 something, maybe 30 something classes, and it was pretty good for a domestic environment. And the idea is that you then replace those with obstacles, you detect the walls and so forth. And so here's another shot. You can see that there are April tags in the background. The camera could absolutely have detected walls with plane detection, but given kind of time constraints, and also there's some with the passive stereo cameras, there was some concern that like the walls were a little bit patchy because of the solid color of the walls. So I ended up
So
using April
that
tags.
that problem has been mitigated to a large extent by OGD Pro,
Yes.
which has active illumination as well.
Yeah, great point, and that's a great product, by the way. So now they have like the OD Pro, which has active depth. It's not time of flight. I think it's structured light, or like a dot projector, but that solves a lot of these like problems. But in principle, it can still work, and keep in mind this was all under some pretty tight time constraints. So again, I'll go back to this shot of me, and you can see like the couch and the suitcase have been replaced with obstacles. The walls are aligned and so forth, and then I'm tracked as an avatar. And of course, I relied on the headset slam for its own tracking once things were synchronized to the camera. I had like a whole procedure for that, a little bit beyond the scope of this presentation. But again, the key theme is that the technology has advanced to a point where you can really do a lot with very little, and you don't need to sort of like if you were designing these systems from scratch today, you really would start thinking in a different way than you would say a decade ago, about what the best way forward is. What kind of the future-proof way is. So I want to so this actually ended up leading to a startup that I'll talk about in a little bit, but I want to take a diversion first because it kind of sets up some things about what I'm doing now. So the question that I asked, now and also at the time when I was doing this project last year is like, where is VR heading? And if you look at like kind of the evolution of devices, so these are you got the Oculus. I think that's actually the DK1 or 2 on the left, one of the first commercial.
Yeah, I
headsets.
recognize the big flat front there.
Yeah. Things have come a long way, right? And then you have the HTC Vive, which was a great commercial headset, but still required. Both of these headsets required external tracking solutions, meaning you have to set up like these base stations and stuff. And they were both tethered to PCs, actually, which is another big point. But then came the third one is the Oculus Quest. The original Quest came out in I think 2019. I think 2019. I think it came out actually. And the big thing about that was no tether, so it had all the compute on board. No need for external tracking. You could kind of roam around. It was amazing. And they began in that series. They began introducing pass through, which I'll talk about in a moment. They weren't the first by any means, but it was certainly the first widely available headset that had it. And coming this October, on the right here, and it's already been leaked. Someone allegedly left one at a hotel room. Is what's going to be called, I believe, the Quest Pro. It used to be called the Project Cambria. That's Facebook's or Meta's next headset. And the big thing that's going to be present on this headset is something called pass through. So pass through or video pass through AR basically just means like taking the cameras on the outside of the headset ideally cameras that are positioned like as close as possible where the eyes actually are, with RGB input, and bringing them into the headset itself. So you can actually like, so it's like you put it on and you still see the world. Which sounds kind of like a goofy concept. Like, why would I put on a headset just to see a video feed of the world? But the reason is that you can do augmented reality in a really, excellent way. So here are a couple, like, so on the left, this is a shot from through the lens of something called the Lynx R1, which is kind of like an open source headset being developed by someone named Stan Laroque and his team in France. Um, and on the right is actually a conceptual rendering more than a real one. But this is kind of where they're imagining things going. Like if you want to have infinite screens, for example, while wearing a lightweight headset, you'd still be able to see your reality, but you could put things in it, which is kind of nice because like it's in a way the opposite of kind of what VR is trying to do. And what I personally and many people in space think is actually where these headsets are going to really be useful, is actually like being less immersive and just making um, existing devices kind of disappear and being able to do things in a more flexible way. Um,
It's a similar device already in the market is the Magic Leap 2, which is
yeah,
also a pass through, and I have actually tried it out, and it's really magical, right? I mean, you can see that um, it still has some ways to go, but you can still see the potential because the field of view is pretty wide. And then it's magical to see that a helicopter landing on your table, for example, right?
yeah,
So it is it's getting there. It's very expensive. I think it's 3,000 something. And it's not really targeted towards
Yeah.
consumers anymore. The Magic Leap 1 was for consumers, but this is for enterprise mostly. So maybe you won't find fun apps on that platform. But the potential is there. It was eye-opening, so to speak.
yeah,
And it only cost the investors about what, $2 billion, something like
yeah,
Well, I think
that.
that's a different story. That's a different story. And I mean, if you should think about VCs as the most socialist people out there. They take money from rich people and distribute it among among the middle class and others, right? So that we can
real
enjoy it.
real life Robin Hoods, huh?
Well, until when they lose, then we win. But when they actually succeed, then they kill everybody else in the space, create
Yeah,
monopolies by just but we are diverting from
yeah,
the
and
main.
also San Francisco politics. It's true.
Um, I do want to correct one thing though, Satya, that you said. The Magic Leap is not pass through AR, so this is an important point. There's so I want to contrast it against it's what
Interesting.
we call optical see through, or optically transparent, or just transparent AR. Sometimes people call it
Yeah.
additive light,
Hmm.
meaning that there is a. I'm sorry, I'm adjusting my AirPod Pros. These things have a tendency to pop out of my ear. Um, so the difference. So this is an interesting point. So I got started on HoloLens, which was also like the Magic Leap, a transparent AR system. So that means like you put it on, and it's a clear lens of some sort, clear
Yeah.
visor, and there's a waveguide in there. Like this, there are other ways to do transparent AR. By the way, I'm not going to get into them. There's like bird bath optics. There's like other things where like you reflect something off, but they're all nonsense, and like nobody uses them in like actual like real world scenarios. Honestly, like I'm sorry, they do, but like for consumer kind of when we talk about AR, like it's really kind of boiled down to waveguides,
Hmm.
which are fascinating technology. And Magic Leap actually uses waveguides, so when you put it on and it's off, you can still see through it.
Yeah.
um, and this is kind of an
So,
example of like a typical waveguide. And the thing is that pass through AR actually has a display. So when the device is off, you see nothing. It's like you're putting on a VR headset. There's like it's opaque to the world. There's literally like a micro LED, or an LED OLED or something panel in front of your eyes. And until it's turned on and passing through the camera feed, you can't see anything. And it's like, why would you do
I
that? Like,
got
why
it.
would you not just
Right,
show?
right. Okay.
Yeah,
That's an interesting point. I had actually not made that distinction, but you're right. In case of Magic Leap, the lens itself is transparent,
yeah,
and what you're calling pass through, and I mean you're an expert here. I don't know the terms properly, but what I understand is that it is actually an opaque display. It is just using cameras to pass through.
yes.
Okay. Okay,
exactly.
now I
And
understand.
it's kind of a, when you first hear it, it's like kind of a zany idea. Like especially after, for someone like me, when I first heard about it, I was like, this sounds a little bit nutty, but like it actually does make sense, and it offers some interesting advantages. It's not perfect by any means, but it's like, in fact, if you think about like AR Kit or AR Core on the iPhone, technically that's passed through AR as well, because it's taking the camera feed from your phone, rendering
Yeah.
on the screen, and then augmenting it, which has some advantages, some disadvantages. Um, so the advantages over transparent AR are that, number one, like field of view for now. So the field of view of a VR headset is significantly better. Even right now, they're nowhere near like a human field of view, but they're, I think, I can't remember the Oculus Quest, honestly. It's like somewhere around like 90 horizontal or something like that. It's pretty good.
Yeah.
Waveguides typically, you'll be hard pressed to find like I don't know what the Magic Leap 2 is. I believe it's on the order of like, I think it's something like, they say like 50 degrees, but that's diagonal. So I want to say like horizontal, it's like in the 30 something range, which is pretty narrow. HoloLens was even
Mm-hmm.
worse. And Magic Leap 1 was only slightly better than HoloLens 1. And there's some physical reasons for that. For those that are curious, so if in this shot here is pretty interesting, because you'll notice that like there's a lot of transparent area on the I guess you call it like the lens, but a lot of it's wasted, because, well, not wasted, but I mean it's just really kind of the way waveguides work. The actual blue rectangle is kind of like where the field of view actually is. Like that's actually where you would see the image, and the
Mm-hmm.
reason is that the projectors are somewhere in the top right. They're projecting into the waveguide, and it basically has to like it's way beyond me. The physics are absolutely fascinating and complicated, but it basically like has to there's a region that's devoted to kind of expanding out the light horizontally, and then like doing that again vertically. And so all of that takes like all that. So the reason the light like bounces around, and it kind of the path gets longer every time, that takes a lot of space, and that's not usable for like visible display. And then when it finally enters like the visible waveguide portion, you're left with like only a small part of it, and so the field of view is constrained. It like can never fill up the entire frame is the problem. You always need
Hmm.
this like horizontal pupil expansion, vertical pupil expansion, and that's a problem, and that makes it very hard, extremely difficult to expand the field of view. So that's why like when HoloLens 1 came out, people were like, oh, we're going to have like AR glasses in 4 years. Like, no way. It's not a Moore's Law type scaling. It's been, gosh, like, I mean, for like well over like a decade, there hasn't been that much progress in waveguides. I mean, there definitely is progress, but it's still like really, really far behind a typical VR headset. The other issue with transparent AR, and where pass through has an advantage, is opacity. So the problem with things like Magic Leap is that the visuals can never really be opaque. They can kind of fool you to some degree. Like I know Magic Leap 2 especially is proud of they have like an LCD layer where they can like turn on these dark pixels to create, block more light, but that's not perfect. It's not like you can never really quite get it to be like pixel perfect. So you don't really have the concept of like black or dark pixels, and that
Hmm.
means that like, especially when you're in bright light, you really notice this. Everything kind of has this like transparent look. It's because it's additive light. So basically, like you can't really have black, because black is the absence of light, and all these things can do
Yeah.
is project light into your vision. So that creates like a very distinctive aesthetic, which in the early days, they're like, even myself, like I was building like these helicopter games and stuff, in Hololens. It was really cool, but at the end of the day, it's just not really like it's objectively not as good as having like a proper display that can render any color, and also the colors are just bad. Like color fidelity on
A little
waveguides is
bit
a huge
washed
That's
problem.
true.
out.
they're,
Yeah.
they're, they're washed out, and they're not uniform. It's like a great test. And there's a guy called, I should have linked him. His name is I believe it's Carl Gutak. He has a great blog. He's an expert on displays, and he has a ton of material on this, and like comparisons and so forth. Like a great test is like you try to render a white rectangle on something like HoloLens or Magic Leap. You'll notice that like it's not actually white, and it's not uniform across the field of view. It like starts to deteriorate. There's all kinds of like there's like things called like tiger stripes and other artifacts, and
Hmm.
it's the, partly because of the way waveguides are designed, it's incredibly difficult to keep them like properly controlled. And
Hmm.
Right.
yeah, devices just don't look that great. HoloLens 2 famously was a major fiasco because they chose a very unusual um, uh, display driver. They weren't using like just something like the industry often uses something called LCOS, which is like you project light. There's like basically a CMOS um, chip that has like essentially it's liquid crystal on silicon, and they turn on and off these pixels that like will transmit or reflect. And HoloLens 2 went with some like rapidly moving MEMS mirror and like a laser. And so then that it just all caused all kinds of problems, and that's why like HoloLens 2 displays, for example, although having a wider field of view than the first version, have incredibly poor color compared to the original HoloLens, and by some measures like slightly worse like clarity. Um,
And these
lastly,
are also those are also usability problems. They're
yeah,
not just aesthetic. They really
absolutely,
are. They matter in a huge way because not everybody's eyes have the same capability to differentiate colors in the same way. So even if it kind of works for the average case, it's still going to fall apart for huge segments of the population, and that means it's not a good
Yeah.
solution.
exactly, yeah. That's a huge problem. And so Uh, the other thing is power. This is not. I mean, this is not actually a issue of the display per se. What I mean in this sense is I'm kind of actually kind of getting ahead of myself here. The Magic Leap and so forth notwithstanding, they're kind of targeting a strange, very niche space. Typically, what transparent AR is being viewed as by the industry as being good for is some sort of all-day wearable, so something that will eventually have like a sunglasses type form factor.
So,
Not Microsoft, sorry, Meta is definitely working on something like that, and it's generally Snapchat has their spectacles. So when I think of transparent AR and what future it has, it's definitely being considered for those kinds of applications, like something I can wear all day that has every now and then will show you information or something in a very lightweight form. Um, so that's kind of I think where a lot of things are going now. That's where transparent AR. That's what transparent AR is good for. You can put it in a big form factor like the Magic Leap with a puck on your that you wear on your hip that has like a ton of battery life and whatever can pump out tons of pixels. You can definitely do that. But generally speaking, I think the industry is moving towards okay, like this is going to be for an all day wearable type scenario. So that means that typically transparent. Like when I look a few years in the future, I kind of expect that most transparent AR devices are going to be extremely low power because of that use case that they've identified for. Not anything to do with the display itself. But you'll see why I mentioned this in a little bit.
And I think that's similar to how we've seen the wireless headphone industry sort of take off, where
Yeah,
even the first good ones were you'd get maybe an hour, because the battery tech wasn't there yet, and they were still too power hungry. And now with the newer Apple AirPod Pros, for example, they were saying like 6 hour talk time or something, which is
yeah.
yeah,
that's all day. Yeah.
exactly. Yeah,
Yeah.
yeah. It's incredible progress that has been made on this actually. But yeah, and so the challenges, by the way, with this, I want to just talk about some challenges. I have to speed up some of these slides, but some challenges with video pass through, dynamic range. Obviously, your eyes have enormous dynamic range. It's surprising, but if you look at like how like the intensity of light um, that we have to process as humans varies enormously, like much more than people estimate. So like here's a great slide that I found from the University of Washington. It's about like if you have a piece of white paper, if you're out on a moonless night versus like at noon on a sunny day, the difference in brightness, like the difference in light intensity reflecting off that paper is on the order of a billion. So like 10 to the
Wow.
ninth, right? That's
Wow.
that's 9 orders of magnitude. People like intuitively you'd be like, oh, maybe it's like 100 times different or something. No, it's 9 orders of magnitude different. That's the challenge
Wow.
that cameras have, right? In being able to um, amplify light that's really dark, but also not get overwhelmed in sunny light. So that's why like obviously if anybody who's played with the camera understands that when you point at a bright light,
Mm-hmm.
it like they'll have like auto adjustment of the exposure times and so forth. And so that as you can imagine is a huge problem for both the camera side and the display side of video pass through. Right, that's something that is really hard to solve.
Yeah.
And right now, for a long time going forward, they're not going to look exactly like your eyes do. There's going to be some issues with these kinds of like how it actually reproduces colors under different scenarios. Um,
Mm-hmm.
Latency is another big one. So the whole pipeline for video pass through looks kind of like this. On the left, you have a photon coming into a camera sensor, probably a CMOS camera sensor that has to be processed in the way that any camera processes video. They call that terminology. It's an image processor, basically. ISP is sometimes the term that's used just to get that like frame and convert it to something that's like RGB. that then can be processed by the system. Then it goes to some other piece of silicon that renders stuff on top of it, and then maybe reprojects it and so forth, and then that gets sent out to a display that produces photons that then hit your eye. That whole pipeline has latency, and it's on the order of double-digit milliseconds. Ideally, you'd want it to be like at 60. So just to put things into perspective, 60 frames per second is 16 milliseconds per frame. And that's still probably too slow. Like these VR headsets now are running at I think the Quest 2 can do up to 90. I think there are some that do 120 hertz. 60 hertz is considered very low for VR and might even make you kind of sick. So now, let's say you're doing 120 hertz, that's 8 milliseconds. And that's actually really tight for taking an image from an RGB camera, processing it, and then rendering it and so forth. So there's some definite challenges with latency.
Yeah, and those lower frame rates really do affect your body in unpleasant ways.
Yeah, absolutely. Yeah, it really makes you
And
sick, and so it's not the only thing, but absolutely, it's a big part of it. Perspective correction is another challenge. The cameras are not actually at your eye, and while it may seem like a small difference, like if you put cameras in front of your eye, you kind of fold your eye sockets out, it does actually shift your perspective considerably. Like we perceive depth through stereo, and our eyes are pretty closely spaced, right? You're talking on the order of like 60 millimeters between pupils for most people, like 55 to 65, something like that. So small differences make a huge difference in your perception, and that means that you have to have some way to correct that, and that's difficult because if you don't have a camera actually in your eye, there's certain things you can't see and vice versa, right? So how do you do that, right? There's some ML involved, some clever tricks. When you shift those cameras around, you might see things like I'm looking at a table. If I were to move my eyes forward, I might see some things beyond the table. In other areas, I might not see things, and so forth. How do you do that perspective correction? It's still not a fully solved problem.
right.
And lastly, resolution. This is a problem actually for both transparent and pass-through AR. You want to get that retinal resolution, and that what that means varies. It's actually kind of hard to nail down a precise number. There's some studies that suggest certain features people can perceive at like an 1800 pixels per degree resolution, which is crazy. There's some studies that say like an optimal is somewhere around 150 ppd. That's pixels per degree of your field of view. Just for comparison, so let's say you take like a number these numbers might not be correct, but I'm not a vision scientist. This is a whole crazy topic, but just as like a ballpark estimate here, the Quest 2, I believe, from what I looked up, is 18 pixels per degree. It's display. I think they use like 2K displays per eye or something like that. So 18 pixels per degree. It's not good enough to read text, and its pass through is pretty poor. You can't read like text off of a computer screen if you're in that. It's just too blurry. But you need so you're talking you need extremely high densities of not just the input camera, but the display. So there's definitely some challenges there. So anyway, that's where VR headsets are heading. The industry is definitely heading towards pass through. Like there are tons of devices already on the market. There's like the Vario, the Quest have some rudimentary pass through. The upcoming PSVR has pass through. Obviously the Quest Pro and I think everything after it will have pass through. And I'm aware of actually several other headset manufacturers that are going to be introducing pass-through headsets literally in the next 6 months. There'll be several announcements. So that's kind of just where things are heading. It's a great technology for many reasons. If you can put on your headset and be able to kind of still do what you're doing, that's a huge, it just opens up a lot of possibilities. So going to February 2022, this year, I left Apple and I was kind of just goofing around with some projects, looking for an idea. And I spoke with Six Liv, who's really been a pioneer in the VR fitness space. Saw the potential of fitness in VR early on when people didn't believe that anybody would want to put on a headset and sweat it out. And he kind of, we started talking. He came in with this idea of he wanted to do a new company. He's got a couple companies in the XR space before, and he wanted to do something new. And he'd been kind of thinking about sports, what can be done with sports and VR, specifically, with sports being something that you have orders of magnitude more users spectating than you actually have to have playing, which is great because right now VR headsets are still kind of only slowly penetrating the market. But wouldn't it be cool if we could have something where not everyone has to have it to enjoy it, but if we could create something that people enjoy watching while a smaller subset of people need to be playing it. And that
makes a lot of sense.
I'm sorry.
It makes a lot of sense.
Oh yeah, yeah, absolutely, yeah. So it's like that's kind of thinking about it from like that business standpoint, not being gated, not having your distribution gated by an app store with opaque rules. For example, as you see on Quest, one of the problems is that most games just don't ever make it to the app store. It's very hard to actually get on the app store. So this idea of sports, right? Like physical competitive activity that's fun to play and exciting to watch, and that requires having some athletic ability, and in order to progress in the game, you have to kind of improve that ability. We've seen this countless times in pop culture and movies, right? This is a shot from Tron, I think Tron 2 probably. We've been seeing this idea of like in the future people are playing these like virtual, augmented, futuristic sports, right? Like, so what like is the time now to do something like that? And I think the time, we are at the verge of being able to make this possible. So the startup we decided, and I thought like when I saw this, I immediately thought, we were talking about it, I was like, hey, I just did this MR laser tag thing. I love co-located, meaning AR where people are in the same space together, not just like remote, but I mean like playing together in AR, whether it's playing or doing something serious, is a super magical experience. And I think it's something a lot of the big companies are sleeping on. They're not really like taking it too seriously yet, although I think obviously inevitably they will. When people have devices, you're going to be in the same room with people with a device, whether the same household, wherever. You're going to want to do something together with them and not just be in like isolated, worlds. This whole metaverse idea, I think, is kind of nonsense, and that's a whole other topic. But it's just not where this technology is really, going. I think that's a very like naive vision of what it can do. I think actually it's something that can bring us together and let us have fun without these things getting in the way and killing conversation. Being this like obsessive thing that we look at. Like, can we get rid of? It's more. I think it's more about like ubiquitous computing is the model to think about for VR and AR, more so than some sort of like reality replacement model.
So you're saying fewer bad selfies in front of a bad-looking Eiffel Tower.
Yeah, exactly. Yeah, nobody wants that, right? Like, it's not like nobody's asking to sit around. Like, the whole concept is crazy. Like, and this idea, like, in the last year of like metaverse. It's like, oh, what can we do in the metaverse? Like, in the future, you'll be shopping in the metaverse. You'll be doing this. You'll be sitting on the toilet in the metaverse. It's like, it's not. It's just, it doesn't make any sense, like, to me at all. It's not what anybody wants. People want to connect to other people. Yes, VR headsets can make it possible to connect to people remotely, true, but that's never going to fully replace, no matter how good it is. It's just not going to replace like in-person connection. We want to go about our lives. I think we're all kind of sick of like the way devices take over our lives, and I think that one of the strengths of the medium, AR, is that it can potentially help rectify that by essentially making those devices sort of disappear. And so you're able to kind of focus on being present in reality, and that's so I've always been passionate about that idea. That's I think where AR really shines. And so Six and I decided to start this company called Rec, and it's basically we're calling it Sports 2.0. So we're trying to reimagine what sports will look like in the future, and we're doing it through. We think right now the technology that is best suited for this are actually pass-through headsets, which is a really weird and counterintuitive choice. All the companies right now that are building these things have been on the drawing boards for years. Number one, they were skeptical about fitness in the first place. Now they're coming around because they see it's actually a big use case. But this idea is even like way out there more, right? It's very counterintuitive. It's like, wait, you're going to take these things outside? These things aren't designed for outside use. That's what we'd like in the future. Like, say, several years down the road, what we ideally want is for you to see like once these headsets are small, like ski goggles or something, see that as a piece of sporting equipment, the way you take a frisbee or something to the park with friends, or maybe you meet new friends. Maybe you get serious and you want to compete. Maybe there'll be um, uh, broadcast events of these new sports, right? That's kind of what we want to do with Rec. Um, so I have some footage, and I hope this plays correctly. This will show like a
Cool.
series of things we've done over the last few months since we started coding this in April, roughly. So here you see a first
Yeah, looks
person
good.
view. This is what the Oculus Quest looks like. So you see like it's very low fidelity, black and white pass through. This will get better, trust me. Like
Yeah, but the speed is really impressive here. I know how hard it is to keep stuff in place at this velocity. Looks great.
Yeah, it's definitely, yeah, it's a smooth experience. And here we did a location
Got a
test
live
overseas.
commentator.
Yeah, someone actually they wanted, he played it, and then he really wanted to comment his friend's game. So he grabbed a microphone. He really wanted to like shoutcast. And it was really kind of that. It was
I
really like
love
an
this.
aha moment, right? It was like, wow, this really
Right.
does. This is what sports are about, and people got it. And the cool thing is
Right.
that because it's AR, because you see each other when you're in there, we're using the pass-through mode. Um, Whether you try the VR headset or not, you immediately understand what to do. We don't use any buttons. We're just using the controllers for tracking your hands. There's no buttons in the game. You basically punch to throw fireballs in this current game, and you run to charge them, and you can collect power ups to do different things. But it's all based on punching and running to charge up. So we incentivize motion. It's very, very intense
Man.
athletically, and you just get it right away. It's like, duh, obviously, like, I see everything. I can run around. There's no menus. There's no like crazy interfaces. It's just reality, like reality plus, right? You have
Yeah.
reality plus,
Wow.
some stuff on top of it, and you're there with your friends having a good time. And then people, and the big important thing here is that we have, and this kind of came from the MR laser tag project. I'm actually going to replay this video real quick. We have like the spectating part. It's real time
Hmm.
spectating. So it's not, none of this footage is post processed. We've never shown any footage with Adobe After Effects or anything like that. You can see right here the TV. People are watching live a mixed reality capture. So we have the actual people, which are compelling to watch. You don't want to watch avatars running around. That's actually kind of boring. You want to see like real people, doing their thing. But we have like the graphics overlaid on top in real time. So that there's some computer vision stuff going on there. That's the real magical part about this. This is what makes it,
Wow.
like something you can actually spectate, and something that we're really, really focused on is the spectating part of it. And that all started, yeah, with the OpenCV AI competition. That's where a lot of the stack came from for rec, basically.
It's
So,
tremendous. Yeah, and
Yeah.
hey, I mean, once this starts taking off, if you need a co-host for your broadcast team,
oh yeah, for sure. Yeah, we're definitely gonna. It's gonna be a slow ramp up. We're trying to figure out what we're. Yeah, I mean,
you know how much I love pro wrestling. I've been practicing for this my whole life, man.
people keep telling us we should do something like WWE, where we have like personas and all this stuff
Yep,
going on. I mean, yeah,
I'm
there's
your guy.
definitely. I think that could make a lot of sense. Like when that guy started shoutcasting, it was hilarious, and everybody loved it.
Hmm.
It was just, yeah, that's what makes these kind of activities a lot of fun, right? Um,
Yeah.
but
Wow.
but yeah, still a lot of big technical challenges, to really get this. Because see, we're definitely fighting kind of against the grain in terms of how the headsets operate. We're really pushing the headsets in a way that they are not designed. Like if you were sitting in like a meeting at like a big company like Google, Microsoft, or Meta or Apple or whatever, and like you propose, hey, we should like build a product, and this we should have like people playing sports outside in the park wearing these things, you would never be invited to another meeting again. You'd absolutely just people think you're a total weirdo proposing that, but it's been the case in the space that the fact of the matter is like AR has a problem where people are kind of now that I've stepped away from doing AR in a professional environment, I realized that like AR really does have this problem of being a solution in search of a problem.
Hmm.
People are kind of approaching it as like, okay, this is the next big thing. Like, what are we going to do in this space? As opposed to like, what are the problems we're having and how do we solve them? So what ends up happening is the actual things that take off in the space can often be quite different from what the designers of the hardware envisioned. So, Meta is famously having this problem. Some of the games in SideQuest or App Lab are doing really, really well, much better than the stuff they're trying to curate in the App Store. But it just doesn't fit their perception of what they thought this headset was about. But like once you try this experience, it like definitely makes sense. It's like, oh, this totally makes sense. I can see you, I can run around, we can have fun. We're together. We can then take off the headset, go grab a drink. Things like that. That's a really, I think, positive vision of where this could go. And it's, I think, over time, the headsets will naturally, as they move towards pass through, I think more and more people are going to want to like use these things outside their home for various reasons.
Hmm.
Not walking around all day. These headsets are not designed. These are definitely task-based headsets. But
Yeah,
I do
you're
think
going to
that there
become
will be some things
uncomfortable.
that surprise the people who initially designed them about use cases, and I think ours will definitely be one of those. So
Yeah,
yeah.
it's
So anyway,
already extremely
I,
compelling.
I'm sorry.
It's already very compelling.
Thank you. Yeah,
yeah.
I really. Yeah, I mean, it to us it feels, yeah, like it when we got the first build up and running back in late March. I did like a really simple test. Um, yeah, definitely. We were like, okay, this is really cool. Like, regardless of what skepticism we may have had going in, we tried it out and we were like, this is actually, there's definitely something here. It's not like any other experience. And I like to say it's kind of like potentially a new game genre in the making. Like game genres
Yeah.
don't really develop anymore like that frequently. You see them fewer and farther in between. A lot of the space has been explored, but usually when there's a new technological change, it opens up like new creative possibilities. Like the first person shooter in the early '90s was made possible by consumer grade 3D hardware and computers being fast enough finally that you can start rendering 3D graphics. And
Being fast enough to fake it anyway. Yeah.
yeah, it's fast enough to fake it, and then the internet play, right? Like the whole idea of like death matches, with the internet was obviously something that you couldn't have done as easily, like a couple decades prior. And so I think this might be kind of like something new, like that it's an opportunity to like really create like a new type of game that you couldn't otherwise really do on a computer, for example. And there's a lot of computer vision challenges. So kind of returning back to why we're here with OpenCV, and just to kind of broadly name a few. Obviously, we have to register the spectator camera to the headset to be able to like be in the same coordinate space. That's still a tricky problem. I think the system we have right now is obviously built with duct tape and glue, but it still works a lot better than other mixed reality capture systems I've seen. The calibration process is a bit easier. It still has some way to go to be like actually deployable. So that's a big challenge for me to work on. Human segmentation. We want to be able to have, and we actually have a demo of this already. I didn't show the footage, and we're not going to show it for a little while, but we do have it running. If you can segment out the people and understand what depth they're at, then those 3D effects can go behind them and in front of them naturally, which
you can have occlusion.
That's super important.
Yeah.
High fidelity body tracking for two reasons. The main one is that we want to be able to, again, spectator view is very important. It has to be interesting to watch. People might want to augment themselves with like virtual armor or cosmetics, and to make that look seamless, you have to have really good, very accurate, meaning and very fast body tracking to do those augmentations, as well as potentially to kind of maybe act as a tracking camera as well. So that if the headsets start to drift or get desynced, if we could always do that tracking in real time, that'd be great. If we have like a backup outside in tracking system, that'd be awesome. So there's a lot of challenges to work on there, and even environment mapping. So I think the headsets themselves are going to provide this. They're going to have, I believe the Quest Pro has a depth camera, and if not, there are definitely others in the works that have them. The HoloLens had a depth camera. Magic Leap has one. They've had it since 2016. Being able to kind of like map out, where is the ground, where are the walls, so that you can really explore scenes. So like when objects hit them, they behave in a realistic way. Or we in our latest build, we actually have ground shadows under the particles, so that you have a sense of like depth. Like if you're watching, like where is that particle moving? It's hard to see without like some sort of depth cue, like a shadow.
Yeah,
and for that,
triangulate. That's great, and the Valve Index also has that 3D room view for additional tracking help, which our friends at Arcturus Industries worked on.
Right. Yeah. Exactly. Yeah.
So what I also find fascinating is that it really hits the sweet spot, right? First of all, people think that, when you're using AR, VR, etc., you are in isolation and you are meeting other people virtually, right?
Yeah.
But here, it actually brings them in real life, and you're actually doing a real world activity together. And the second thing is that, which you really nailed, is that the technology is not really there yet, right? So you cannot actually spend 6 hours wearing these headsets, right?
Right.
But you can easily spend an hour playing with a friend in this environment, right, where other people are also watching the game, right?
Yeah.
And there are spaces like this. The final piece is that there are spaces like this, at least in the United States, where especially for kids, like Rock and Jump and uh, places like this, where they are dedicated to activities, physical activities, right? People go and do trampoline and other activities. So you could have a dedicated space where everything is calibrated. They just go and put on this headset, and they can have a fun game.
Yeah.
Many people can have fun games, right? So
Yeah.
this is also a bridge. This is its own thing in itself, but it also utilizes the technology where it's the technology is not as good as it would be in, let's say, 10 years, but there is still a viable business and a viable application that you're bringing to the world, right? When the technology is still not quite there
Yeah,
Yeah.
fully.
exactly. Yeah.
That's
I
fascinating.
know, Bart. I know you gotta run pretty quick.
Yeah,
Go ahead and you can wrap up
I
here.
talked way too long.
It's
I'll
all
skip
good.
ahead and just say like, I went over the other slide. Basically, fitness has a wish list. Obviously, lighter, more comfortable, leg tracking, fast hand tracking. Right now, it's a big problem. Fitness is a use case, but the headsets were never designed to track hands fast enough. Someone's trying to call me here. I think they're trying to kick me out in a second. I know
You'll
it's
be
kind
all
of odd
right.
because like it's still 5 minutes to go, so I'm not sure why they'd be doing this. Um,
Oh no, they should be leaving you alone. We got you till 10:30, bro.
Okay, yeah, someone's very insistent on ringing, but it doesn't bother me. If you guys can't hear it, hopefully.
Nope, can't hear it.
Um, yeah, so thanks. I actually have to get going in about. I can stay another 5, 8 minutes.
Okay.
And I'm sorry to take so long. I didn't realize I was taking that long, but I'd love to take questions if anybody has them.
Yeah, definitely. So we got a couple good questions here from folks. We'll do our giveaway after Bart bounces here, since we've only got him for a limited time. Richard in Zoom here would like to know a question which was on my mind. Have you gotten to try out the Tilt 5 yet? Have you seen this? They've shipped, and it's, I think, the forerunner of pass through, augmented reality stuff on your tabletop. Have you gotten to try it out?
Yeah, so Tool 5 is a really innovative product. It's actually kind of neither. It's in a
Hmm.
different category of its own. It's almost like a form of projection mapping where the display.
Sure.
So there is no. The beauty of it is there is no like display. They actually have a projector that projects out, and you have to have that retro reflective mat. Basically, the idea is that it reflects it back, and then you see it, and it's like perspective. So they track your head, and then they know where you are relative to the mat because it has
Yeah.
some image markers on it. And and what's amazing is that the technology is like pretty clever because it actually solves a lot of things that are otherwise hard in AR. Like if you put your hand up in front of it, your hand will occlude it perfectly because
Hmm.
uh,
You're
yeah,
blocking the
basically,
reflector. Yeah.
yeah, exactly. It doesn't reflect off your hand. Now the downside is that you can never do something. Now, so see, like in pass through, video pass through, you could do something crazy like have virtual objects where you put your hand over them, but also put your hand behind them. So like you can imagine using CV to segment out your hand, understand the depth, and rendering things on top of your hand. There's you can pretty much do anything, right? You're essentially completely re-rendering reality. Tilt 5 is still kind of in the domain of things like transparent AR, where you don't really have that ability to do that. You
Hmm.
can't like interleave things easily with like reality, and you're constrained to the tabletop. It's really really cool, and I wish them a lot of success. And they have a very focused use case, which is board games. For us, it obviously doesn't really have any alignment, but it's another great use case of social AR, right?
See,
Where the
I'd be
whole
interested in,
yeah.
I think you could watch a match of a rec sport,
Oh yeah, yeah,
with it over top of the
yeah,
field on Tilt 5, and that would be really compelling stuff.
yeah. I think that absolutely, you're absolutely right. We could do that with something like avatars or whatever. Or I think in the future, what we could do is basically have like say like a nerf, like a nerf capture or something of spaces, and then be able
Yeah,
to like re-render. So you could have that like moving camera or let users control it, but like with the actual real world, arena. I think the possibilities are going to be endless. Yeah,
yeah,
absolutely.
yeah. The only problem is deciding which thing to do at this
Yeah,
stage, and
in what
a
order
lot of
exactly?
this.
Yeah, that's the whole
Yeah.
like challenge here.
Um, Ken in the chat would like to know how well does eye tracking work to render higher resolution, but only where people are paying attention? Is that something that you really spent any time thinking about or have seen any great examples of?
It's a little bit beyond what I've done personally, and professionally. What he's talking about is foveated rendering, and I think
Yeah.
that
Hmm.
Meta has a lot of great public demos of this, of like the benefits of it. Yeah, it is important because like basically the idea is that your high res. The reason like it's hard to come up with like a definitive PPD for your eye is that like your eye is not uniform resolution, and you have like a very small
Hmm.
area that renders in
Yeah.
very high fidelity with high color fidelity, and then like your peripheral vision is very low fidelity, but very sensitive to fast motion, but not very sensitive to color. And so your brain kind of fills in the rest like a neural network would do. And yeah, absolutely, it's especially when you get to these like super high resolution displays. The whole idea of foveated rendering is that if the eye tracking is fast enough, you could then only render those pixels at a high resolution that are needed, and then the rest of the display doesn't have to quite render at that resolution, so you save a lot of GPU power. That's effectively the reason for doing foveated rendering. I do think that is going to be something that's done in headsets. I don't know if the Quest Pro will have eye tracking. I don't know if they actually have foveated rendering up and running. Again, eye tracking has to work really well. And a problem is that what if it doesn't work? Like some people have like a lazy eye, or some people, lost an AirPod there. Some people, some people just don't get dialed in as well in those systems. Like there might be some spectrum of people that just don't really, it doesn't work quite as well as for others. So there's definitely some challenges there, but in principle, it is doable.
Yeah, that makes a lot of sense. So Bart, thanks so much for joining us here. This was a lot of fun. We wish you all the success and best of luck, and hope to see more awesome content from Rec and yourself. Where's the best places for people to find you on the internet these days?
I just put it there, and then also you can follow my Twitter.
So it'd be
I think Twitter is probably
rek.tv.
a better. I mean, we have links to Twitter. This should be my Twitter. We have links there on rec.tv, and I typically, when there's any kind of news, I'll post it. I'll post it on
Excellent.
my Twitter, so that's a great way to follow me and get in touch with me.
Cool. And that's at Bart Polygon on Twitter and rek.tv on the interwebs there. Go check them out, follow them, tell them OpenCV sent you. You'll be telling people where you were when you saw the first new virtual Olympic game created, folks. You can feel free to drop off whenever.
So I actually if you got to bounce. Really apologize, but I mean, feel free to you can also just tag me on Twitter and ask a question, and I'll try to answer it if I can answer it.
Awesome. Thanks so much.
Thank you so much.
Take care out there. So we've still got to do our giveaway here. For those of you who have never joined us before or need a reminder, we do a thing here every week where we give away something to our audience here watching on Zoom. If you're not in the Zoom audience, you can get there by going to opencv.live. I'm going to ask a question from Bart's presentation, and the first person to answer that question correctly will win the OpenCV course of their choosing. Invest in yourself by learning from the experts at OpenCV. Get ready to answer the question, and if you have not answered, or if you have answered a question correctly in the last 2 months, please don't answer and give other people a chance to answer. So, sorry, my headphone's moving out here. I'm going to do that part one more time. So, one moment, sorry. Ear problems. So, Magic Leap, earlier we talked about them as having pass-through AR, which apparently was not technically correct. What is the name of the technology that Magic Leap uses that we learned about earlier today? Be specific. It was a specific kind of tech. David Wheeler, winner chicken dinner. The answer was a waveguide. So David, congrats. I think this is maybe your second win. We need like a leaderboard here. The Light Twist team, can we do that for next week? I've upset the gods. Congratulations, David. I think you already know my email, but if not, it's phil@opencv.org. We'll make sure you get the course of your choosing. We've also got another thing you can help us out with here. Operator, can we get the cat cam? There's our buddy. So tragically, our beloved in-house kitty cat here does not yet have a name. You can help us try to name this creature by sending one email to newsletter@opencv.org with your suggestion. We will read out the best suggestions on the air, and I'm going to do that now. We got a good one this week from Peter via email. He came up with the name Kapoo. I don't know what that's from, but it's not bad. Ken here in the chat just suggested Robbie. It's in Robbie the robot. For our little robot that hangs out in the secret part of the studio that you're not supposed to see. or Rob, as in robotic operating buddy from the old Nintendo. That could be something as well.
Are we going to do? Voting on these names? How is it going to work?
See, I don't know if you. It seems wrong to vote on it. I mean, I could be convinced. But I think you just, when you know, you know. We're gonna get the right one, and we're gonna be like, oh, okay, that's the cat's name. And so
Right.
we'll just send in those suggestions. Newsletter at opencv.org. Satya, we talked earlier on the show about, some folks maybe joined us a little bit later. We talked earlier that the OpenCV Spatial AI, or the OpenCV AI Competition Spatial AI track has been, preliminary deadline has been extended to September 19. Do you want to remind the folks about what that track really consists of?
Yeah, so OpenCV Spatial AI Competition, now we have two tracks for OpenCV AI Competition, the OpenCV Core track and the Spatial AI track. In the Spatial AI track, we are going to give people Oak D Pro, OpenCV AI Kit with depth, the Pro version of it. And the idea is that we want to get very good depth estimates from the camera. And as people know, it has three cameras. You can use all three of them, and you can also use neural computation on the device itself. So use all of those things to see whether we can get good estimates or not. Right, better
Right.
estimates than regular stereo estimates that come out of the camera. So that's the goal.
And up to 25 teams will be selected to participate in the build phase of that track. You've got
Yep.
until end of day, September 19, Pacific time, UTC -8, to submit those. So, surprise yourself, give it a try. There's also the OpenCV core aspect of this competition, where you can essentially, similar to previous competitions, make whatever you want. It just has to use OpenCV. And in fact, we've got additional prizes from some of our co-organizers at Orbec and Cadres. So take a look at the opencv.org website for full details on that. The deadline for the OpenCV track of the competition is, I think, in October. So you've got a little bit more time there, and it's wide open. So do your best, and you may end up like Bart with a whole new career trying to build the future of sports and fitness.
That's great.
With that, Satya, you ready to take us home?
Yeah, thank you so much. Thanks, everybody. And Bart is not here, but I want to thank him for that excellent presentation. And it's mind blowing. You participate in a competition, and that gets the ball rolling, and suddenly you have a new company, and the trajectory of your life changes, right? And that is why we encourage you to join, participate in our competitions. And I just want to thank the audience for being with us. It's really a pleasure to have you and to do this every week.
Okay.
And thanks, Phil, for organizing this. That's
Thank
it.
you, Satya.
We'll see you
Take care of
next
yourself
week.
out there, folks. We'll see you next week, same bat time, same bat channel, where our guest will be Alex Glow from, you might know from Hackster Cafe. We'll be talking about green electrical engineering, an initiative that I think is really important, especially these days, more so now than ever. So look forward to that. Thursday, 9 a.m. We'll see you next time. Operator, can we get that sweet outro? Thank you so much. We did it, Satya.
All right.
Once more.
Pretty much everything was going wrong today, but
Yeah,
it's all done.
pulled it off. The show must go on, as they say, and it
The show
did, in
must go on.
fact, go on.
All right.
Take care of yourself, folks.
Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by OpenCV Courses. Learn computer vision and AI from the best at opencv.org/courses. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.